So we're going to talk about substitution today, which is a new method for us to solve systems of equations. So last class we talked about graphing them and then looking at the solution. But sometimes we might be given equations that are in y equals mx plus b form, so it's easier for us to solve them other ways instead of rewriting the equations and then graphing them. So we're just going to look at a different method that allows us to solve them today. So when we're solving systems by substitution, the first thing we want to do is we want to pick one of the two equations. So we want to pick one equation to substitute into the other equation. And when we do this, we want to pick an equation that's either already solved for x or solved for y, or an equation that's easy for us to get x or y by itself. So we always pick the equation that already has x or y alone. And if we
Mr. Sabo,
yes. What's up, Riley?
will the notes be on Google?
Yeah, they will. So you always want to pick the one that has x or y all by itself. If there isn't an equation that has x or y all by itself, then you want to pick the one that's easier to solve for x or y. You're not wrong if you pick the other one, you're just making more work for yourself. So in order to make it as simple as possible, you always want to pick the one that has x or y all by itself. Or the equation that is easiest to solve for x or y. So that would be equations where like an x doesn't have a coefficient or the y doesn't have a coefficient, where you can just move the other variable to the other side. And we're going to look at examples of all of this. I just want to make sure that you have steps written down for yourself so that when you're solving these, if I'm not available for you, you can always go back and look at these steps. So after we pick an equation to substitute, the next thing we're going to do is plug into the other equation and solve. And then the last thing we want to do is once we've solved that equation, we're going to use the answer we get in order to solve for the other variable, because remember, we're going to have answers for x and we're going to have answers for y. So then use answer to solve for remaining variable. And this is all going to make more sense when we actually look at it with numbers. But again, I just want you to have this written down, so in case you go back to look at your notes and you forget why we did something or what we did by looking at the math, you can look at the steps too. So if we're looking at an equation, are you okay with me moving this? If we're looking at an equation that we're going to solve by substitution, it's going to look something like this. They're going to say solve the system using substitution. And they're going to give us two equations, just like they did last time. But you'll notice this time I have a y equals negative 2x minus 9. And then my second equation, my x and my y are on the same side. So that's not so great for graphing because it's not easy for us to pick out our slope and our y-intercept. So because these aren't set up and ready for us to graph, it's easier for us to use a different method to solve these. So I have a y all by itself in its first equation, but then I have x and y together in the second equation. So what I'm going to do is I'm going to take my first equation, this y equals negative 2x minus 9, and everywhere that I have a y in my second equation, I'm going to substitute in my first equation. Because if I have an equation that has only x's in it, I can solve that equation. So this is kind of a weird idea to get used to, but basically what I'm going to do is, because I see that in this situation, y is the same thing as negative 2x minus 9. That's what the equal sign means. It means they're exactly the same. They're equal to each other. So that means anywhere I see a y in my second equation, I can replace that y with a negative 2x minus 9. So I'm going to take my equation, my first equation, and I'm going to substitute it into my second equation. The reason I want to pick my first equation is because the y is all by itself. There's nothing I have to do. So if you ever have an equation where you just have a y on one side of the equal sign, or you just have an x all by itself, that's the equation you're going to plug in to the other equation. You don't want to pick the one that has the x and the y on the same side because it's going to make it harder for you. So what I'm going to do is I'm going to take my 6x minus 5, and where I had a y, I'm just going to put a big parentheses, equals negative 19. Because I know I don't want that y in there. I want all the same letters in my equation, because if I have all the same variables, then I can solve the equation. When I have an x and a y in an equation, I don't know how to solve for two different variables at the same time. I can't do that if I just have one equation. So I need to get just all x's or just all y's in the equation. Since I know that this was a y, this whole thing was y, I can take this negative 2x minus 9, which I already know is the same thing as y, and I'm going to put it inside the parentheses. So I'm going to replace, or I'm going to substitute, negative 2x minus 9 into my equation where y was. And I like to make sure I put the parentheses around there so that I know everything in there is staying together, everything is being applied to this 5 that's in front of it, and I don't accidentally distribute wrong or miss a negative. So I always go in and first put in parentheses, and then I go back in and plug in what I need. So now from here, I'm just going to solve this equation as if it was a normal equation. So the first thing I would do is take this negative 5, and I'm going to distribute it so I can get rid of the parentheses. So I'm going to end up with 6x minus negative 5 times negative 2x gives me a positive 10x. Negative 5 times negative 9 gives me a positive 45 equals negative 19. Then I'm going to collect my like terms because I'm trying to solve this equation for x. So when I have 6x plus 10x, since they're on the same side, I just combine them. 6x plus 10x gives me 16x plus 45 equals negative 19. Now I've got to get my x all by itself, so I've got to get rid of the 45. I'm going to subtract it on both sides. When I do that, I'm bringing down my 16x equals negative 64. And then I've got to divide by 16 on both sides to get my x all alone. And when I do that, I'm left with x equals -4. And now, when we were just solving equations, normally this would have meant we were done because we had our answer. But we know when we're solving solutions when we're finding solutions for systems of equations, we need an x and we need a y. So once I get my x, my last step is I'm going to take my x and I'm going to plug it back into my original equation and solve for y. So in order for me to do that, I'm going to take this first equation, the y equals -2x minus 9. And now I could have picked either equation, but I'm intentionally picking the one that just says y equals because that tells me I'm just going to have to plug in and it's going to be easier for me to pick. If you picked either equation, you would be okay. And then where I had my x, I'm going to replace it with a -4 since I know x is -4. So I'm going to end up with y equals -2 times -4 minus 9. And then I'm just going to simplify. So I get y equals -2 times -4 is 8 minus 9. So y equals 8 minus 9 is -1. Once I have an answer for x and y, then I'm done solving. So I need to make sure I have a solution for x and I have a solution for y before I actually am done with that problem. What do you think? Let's look at another one. So this next one is going to ask me to solve the system -x plus y equals 3 and 3x minus y equals -1. So right off the bat, the thing that I notice here is neither of these equations have x or y by themselves. None of them are alone. So in order for me to solve this one requires that I rewrite one of the equations or simplify one of the equations in order to substitute. So I'm going to intentionally pick the top one. I'm going to take this top equation, and the reason I'm taking this top equation is because my x and my y both don't have a number in front of them. They don't have a coefficient. So I'm just going to retake those equations. I'm going to write it down over here. I have -x plus y equals 3. Now I can pick either equation. It's just going to be more work if I pick the one that has a coefficient. So I'm going to take the one that doesn't. And I want to either solve for x or I want to solve for y. Since I see that I have a -x, I'm going to choose to move the negative because if I can ever get rid of a negative, that just makes my life a little bit easier. So I'm going to add x to both sides. When I do that, my x's cancel, and I get y equals 3 plus x. So now I have an equation where y is all by itself. This is going to be my equation that I'm going to substitute in to my second equation that I didn't use. So I can never substitute back into the one that I started with. I have to always substitute into the other equation. So now I'm going to take my second equation, my 3x plus y equals -1, and I'm just going to rewrite it. So I have 3x plus y equals -1. And where I had this y, I want to replace it, or I want to substitute in what I know y equals, because I want my equation to be all in the same variable. I want all x's in my equation. So that means I'm going to take my 3x plus, and where I had a y, I'm going to put a big parentheses, equals -1. And then I'm taking the second part of this equation and putting it in where my parentheses were. So I get 3 plus x in there. So that's the substitution part. That's where the name comes from. I'm substituting in the first equation into the second equation. And then I'm just going to solve this equation. I'm going to simplify it and solve for x, and then I'm going to plug back into my other one. So because I don't have a coefficient here, it's really like I have a 1 that I'm distributing, which means when I distribute, I end up with 3x, 1 times 3 gives me 3, 1 times x just gives me x, equals -1. I'm going to collect like terms, so 3x plus x gives me 4x plus 3 equals -1. Now I got to move the 3, so I'm going to subtract it. I end up with 4x equals -4. So I divide by 4, divide by 4, and I get x equals -1, which is the first part of my solution. And then in order to get the second part, I'm going to take the equation and plug back in. So now at this point I have options. I can plug back in to any of the equations that I used. Normally I'm going to use, and I always really want to use, either of the ones that they gave me, just in case I made a mistake simplifying. I always want to go back to something they gave me and plug in. So I can pick either one. Personally, I just like -x plus y equals 3 better. So that's the one I'm going to use. In order to plug in, all I'm going to do is replace this x with a -1. So I'm going to have -1 plus y equals 3. Two negatives make a positive, so it's really 1 plus y equals 3. And then I can subtract 1 from both sides, and I get y equals 2. So now that I have x and y, I'm done solving that. Do you want to see one more, or do you feel okay with this? Okay, so your classwork